Good morning, everyone. Thank you for joining us today, and welcome to Production Modeling Corporations and Simulate's collaborative webinar here. The topic of today is how to transform your business with digital simulation solutions. We'll be having 3 panelists today that'll be presenting, so bear with us when we have to make those transitions, and we'll try and make them as quickly as we can, keep everything moving. So with that, I'd like to turn things over to our first presenter, Tom Stevenson, and he'll go over an introduction to Simulate. Tom, take it away.
Thanks very much for that, Brian. And good to be here today presenting alongside PMC. I work at Simulate and I have done for the last 10 years. And in that time, I've worked on multiple different simulations across multiple different industries. So hopefully I'll be well placed to kind of share some stories and also answer any questions that you might have about the software. So Simulate was invented in around 1994, actually. So it's been around quite a few years, and it first started off as this board game concept you see here. So this was when our founder was working at a car plant called British Leyland, and they make the Mini, which is a popular car in the UK. Um, and what he found was that all the complex formula about how flow worked was really effective for transforming flow, but it was difficult to comprehend and it was therefore quite difficult to get buy-in whenever you're making decisions. So he created this game, which was a representation of the factory, where there was little poker chips moving around representing cars, and the management team would sit around this board and play the game representing the factory. And what Mark, our founder, found was that there was a lot of buy-in by using this board game because people could see where the issues were. And he found that it was so popular that people were canceling meetings to keep playing this all day and get a better understanding of how flow worked. So with this initial success, rather than wanting to take a huge game around with him everywhere, Mark invented the Simulate software. And Simulate is essentially doing just that. It's allowing you to create a virtual representation of your system in software. And that's going to give you a real nice visual way of looking at your flow, but also a risk-free environment to test change. So Simulate, as a software, there are other softwares out there as well that do discrete event simulation. But our particular goal is all about making it really easy to access the software and also making it really quick to get to value as you're building your simulation. So some of the ways that we do that, how do we make it easy to access? First of all, we allow you to access either online or through a desktop application. You can also share your simulations online, and that means that people don't necessarily even need to have the software to run simulations and get value from it. We allow you to get started with a free learning platform as well, and we have a support team that are there to help when you're getting started. Also, certainly compared to a lot of our competitors, we have a price entry point that is much lower, much more affordable, and we have subscription pricing as well. And in terms of time to value, which is really important to us, so a lot of the development we do is all about making it easier to build models quickly and easier to get to your results. So a lot of the development that we've actually done over the past 28 years has been to reduce the need to code or reduce the need to have real kind of specialist simulation skills to be able to build these models and get value from them. The other thing now is with all the data, we want it really easy to feed that data into a simulation. So we can do that through things like APIs. We can create direct links to other specific software. And especially things like Microsoft Excel, where we know a lot of people house their data, we try and make it really easy to link a simulation to that. More and more, we're getting more sophisticated with being able to build simulations automatically as well. To again, just take information and automatically build a simulation and apply flow logic using that data. Also, if you want to get time to value quickly, you need to be able to run the simulation fast. You need to build it fast and run it fast. So we make sure that our simulations are the fastest to run on the market. So we try and be flexible. We work with a lot of big organizations, but it's also worth mentioning we work with a lot of smaller organizations as well. Some people will have large teams, others will just have general users that they train to be able to use the software. And manufacturing also is a big part of what we do, but there's all different industries in here that can benefit from simulation. So there's a bit of an introduction to myself and the company. But now I will hand over to Dave for the interesting piece to actually see some of the simulations in action.
So thank you for that, Tom. I'll turn things over to Dave.
Hello, my name's Dave Stone. I'm the Director of Simulation at Production Modeling Corporation. We've been in business since 1979 as an engineering firm. We are located in Dearborn, Michigan. We've completed over 7,000 projects in the last 50 years, 40 years. My role here today is to present you with a simulation model we use in our training, and I will present that. We start out with a simulate window that's open. I have opened the window. I will open my model. And again, you will see a model on the screen that was built in our training session. It's a very simplistic model. It shows you different parts of simulate. We have a queue, which we named a buffer. We have an entry point that we named the parts crib. We have an activity that is a saw, a drill, a coder 1 and 2. We have conveyors. We have loader, unloader, inspection buffer, an inspection activity, and then our finished goods. We also have included rework activities that allow you to repair a defective part. On the left side of the menu is the start point, the queue, the activity, the endpoint, resources. That are these people at the top, Frank, Mary, Joe, as individuals or as groups, Frank and Mary, or all three, Frank, Mary, and Joe. We have this panel can be collapsed. We have a ribbon at the top that gives you different functions. This is your run button, your reset button. This tells you how long you want to run your model for, the speed at which you want to run your model for. This rotating 8 you see at the top is the simulation assistant. You click on this and it produces a detailed collection of information that may be useful to you when you're building your model, when you're troubleshooting your model. You can see here it says results period too short. We didn't run it long enough. We didn't set that up, etc., etc. So we click on that. I will run the model now. As we can see, an entity is entering the queue, working through the different stations. We saw that a resource is being called to these different places. And as we slow it down, we see the digital clock here. It's counting forward 3 or 4 minutes at a time, just the speed. We speed it back up, and you can see things are flowing faster. The time and the clock is speeding up. We're getting advancements. We're getting finished goods out, rework, inspection buffer. So I will stop the model at this moment to discuss things. So if I double click on the activity saw, we can see that it has a distribution, triangular distribution for the time that it takes the saw to work. We also have a results button. Gives you that how many pieces were coming in, how many pieces were completed, what was the percentage of work, blocked, changeover, or stopped. We also show you that because we call for a resource, shows you that we're starved. The little icon with the pie, if you click on it, it brings up your pie chart with those same things, giving you were working 62% of the time, you were stopped 26%, and you were resource starved for 10%. So you may need to add another resource to that activity. If we continue to look at different functions, I click OK to get out. Now, this one is a fixed distribution on the drill. It always drills for 5.2 minutes. The results there, exactly the same that we had before. Efficiency, as you can see, efficiency is grayed out. And that means that we have set if on a breakdown. So we have some visual logic behind this, calling out different activities that are done. So I click that. Okay, I'm back to the regular screen. Routing in and out. This is how we flow from parts. So routing in to the drill is coming from buffer 2, which is a queue. And I have a priority setting on here. We could have collect, passive, expired, oldest, youngest, longest, circulate, locked, uniform, and such. Now we look at routing out function. This tells you where you're going to send it. We ignore blocked routes. We circulate. We have a uniform. We can do percentages, and we'll show you percentages in a moment. So I go to the inspection, and I do the routing out. And you can see here I have it set at a percentage. This allows me to set good finished parts going out. 15% are reworks. So that goes to the rework buffer, back to rework, and then back to the inspector again. Efficiency. Now this one is not grayed out. The operators are 100% of the time. So the inspection process is always available. You can do shifts on this. And it says direct use to shifts, yes or no. And where do we find that? So we click on the ribbons at the top. So the home button allows you to bring up the results manager, charts, income statements, cost by work, duplication wizards, data and rules. Here's your calendar, your shifts, your properties of your clock, distributions that you may create and use within this thing, spreadsheets that may be available, information store. What's in the information store? Create a global variable, simulation objects, and then scheduled maintenance, inputs, job matrices, Excel connections. If you have an input from an Excel sheet or Google Sheet, you're able to insert. Inserting. We can do a background. We can do a PDF. We can do an AutoCAD drawing. Charts, tables, visual bar, data. The view. How do you want to view it? You want to view it with a quick view. You want to with a ruler. You click on here, and here's the ruler. Click it off, it turns it off. Visual Logic. Now this is a form of Visual Basic. You click on this, and you can access the logic that has been written for this model. In-run logic. Oh, and anytime you see the green color on here, this is a comment that is saying obeyed when the simulation reaches the end of the results collection period. It presents you with the data. Here's the next one. Saw on repair complete. Saw on breakdown. Rework route logic. And again, you can see it's commented. Selecting rework for value size. On the left side of this panel is the basic commands set, call, if, else, while, until, an array, a clock, a component, a conveyor, custom properties, recents, your favorites. You can add those, create your own quick library to execute commands. Advanced. Now we're getting into OptiQuest, StatFit, sensitivity analysis. Those are way to run. Scenario Manager is another one for optimization and distributions. You want to do more with your model. This is a very basic model, and we will go back to home and reset it and run it to completion. We will speed it up, and you can see, you can't see anything move, but it's finished. It ran your 1 week. It collected the data. Here's your breakdowns, average breakdown, repair times repaired. Here's your finished goods count. And you click results, you can see that time in the system for these within the limit, 3%. You can bar chart this. It gives you how long you were in the system. Down at the bottom of this left-hand panel is advanced building blocks. Conveyor, loader, vehicles, tank, process oven. Work state item charts. You can create charts that tell you what state you're in. So are you starved, blocked, working? These are, as you see, I'm hovering over the saw and the statistics are showing up. The utilization, starved and blocked. Some more activities, and then value stream mapping. You want to build a supplier, your inventory, your process, your customer, your resources. You want to do create a Kaizen event where you're working on an area in there. And those are some of the features of Automon. Now we'll turn it over to Krishna.
Hello everyone, so this is Krishna here. I've been a simulation engineer for TMC over the past 3+ years, and I've worked on several projects building complex models using Simulate. So we'll be looking at a more complicated model which we built for a client, and it's an aluminum scrap recycling simulation. It was a greenfield project, so they came to us with an idea of the scrap they are planning on buying, and they wanted us to plan for the capacity required on the line, as well as the total distribution of scrap they need, what changes would be required, or if they require storage space, how much would that turn out to be. So the flow of this simulation goes with the entry of scrap. So all these green boxes that were there in the simulation is the scrap entry areas. And this flows through a line where the scrap is cleaned. The scrap comes under different categories. Some are cleaner, some require processing. So the ones on the top here require processing, and they go through a coal line, which literally beats up the scrap and cleans it up. And that cleaned up scrap is stored below in storages. This is an intermediary storage that separates the cleaned up scrap and the scrap that is directly ready to go into the furnace. The green boxes you see here are the cleaner scrap, which can directly enter the furnace with lesser processing. Now, at this furnace area, we have several complicated rules to input and pull out material from the furnaces. And in order to do the calculation and decision making becomes difficult because of the complicated rules. So simulation is helpful in deciding quickly and experimenting with different scenarios here. And another challenge that they faced in this situation was they had two different alloy types. So each of the scraps that come in pertain to either an alloy 1 or an alloy 2. And when they are running one alloy, they cannot use the second one. So they will have a buildup over time. They needed to plan for when is the accurate time to change over from one alloy to the other. And if they increase that duration, how much would their storage increase? These kind of complexities were seen in this situation. where the simulation helped them come to a better understanding of your process and make a more well-informed decision. So if you notice over here, you will see that there is only a single start point, and all these other boxes, which you see in either yellow, green, red, they are all the activities. The graphic has been changed just to represent the different states. So yellow would be waiting, green is working, and so on. So there's only a single start point in this simulation, and that start point sends it to this one activity, and this activity has some visual logic in it to split up and break up all the scrap required and enter it into these queues in all these green boxes. This is done because we have a complex entry pattern which is not directly doable by the start point. Now, after the processing at the furnace, it goes through the dummy holders, and at the holder, it needs to wait for a period of time before it can be casted out. Now, their end goal of any business is always the output. So they were interested in assessing what is the total throughput from the facility as well. Now, as mentioned by Tom in the beginning, we have connected this with an Excel spreadsheet. So an Excel spreadsheet makes it easy for any user to quickly look at what and all details are there. And in case they want to make changes, they can always make that changes and try running the simulation. So if you look at this spreadsheet, the first two tabs in blue are the input tabs, where we have several different inputs that are being put in Excel, and these are read into the model directly and they impact the model. So we have several, these are all the activity names that are used in the model. This is your different steps. Then we have the different inputs. So these are the inputs that come in at the green boxes, which is your different scraps that are entering throughout the simulation run. And then we track these outputs. So these outputs are being tracked in the simulation model as well. But when we print it out and collate it, it becomes easier for a user to analyze it or to process it further to get a clearer understanding. So here we are printing the cost per day, and we have several other information on the right, which helps them make a more well-informed decision. This is the time and state, similar to what David showed in the pie chart, except this is shown in a stacked bar chart, and you can see for all the processes in a single view. It makes it more easier for a person to quickly comment on whether the machinery is running on overcapacity, low capacity, and to quickly make decisions on the same. We also track this work in progress to get the total storage between different areas so that we can comment on the storage situation with different scenarios. And this one is the total input of scraps used during the simulation run over a long period of time. So this would give a brief overview of this entire simulation. Now we can quickly look at a few small visual logics just to get a good understanding. So there are 5 different places where visual logic can be written. This before selection of the part, after the loading of the part, and then at the exit after your work is done, just before you exit the machine or after exiting the machine. Now, this is a logic just to decide whether a part is good or bad. So it's like in case the part is rejected because of a defect, so it just routes it to this rejected area. And if it's good, it goes to the next one. So over here, we just kind of assume this is the distribution that decides that like 95% is good and 5% is bad. and then we just set that value to the label. Once we set it to the label, we route out based on label. And if it has a value 1, it's rejected. And if it has a value 2, it goes through. This is a pretty simple visual logic. And there are more complicated visual logic. So like this one is a visual logic which inputs all this crap into our simulation model. And this is based off the inputs from the Excel sheet. So depending on the complexity, the visual logics can be added in. All these are different visual logics that have been used in this simulation. I hope that explains this model in a brief overview. So I'll hand it back to Brian and we can go through the questions.
The first question we had, I'm not sure who wants to answer, but it is, what different types of downtime are there?
I don't mind taking this one if that's
Sure, go ahead.
good. Yeah, and then anybody else can chip in as well. Um, Downtime for me comes in two categories really. You've got that planned downtime, which might be that you plan to shut down your plant for a certain amount of time to ensure that everything's ready to go. And also in terms of downtime that you plan would be things like staff shifts, or maybe you don't run every single shift, you might have downtime there as well. So we have those options in Simulate. Also, you might have unplanned downtime as well. So these are, downtime that's going to happen throughout any process. Things like um, if machines have breakdowns or if your workers need to take a break. All of that we can capture as close as possible to reality, basically knowing that actually the system is never going to be perfect. So we want to capture that in the simulation so that any advice we can give from a simulation is true to what it's likely to be in reality.
Okay, thank you, Tom. The next question we had, how do you input data from an Excel file into the simulate model? Dave, Krishna, Tom?
Yeah, so I can take this one up.
Okay, thank you, Krishna.
So in the visual logic, we have commands that can directly take in data from an external source such as Excel. And additional to this, we also have other functionality in Simulate, which can link a Excel workbook to the Simulate software. So at fixed intervals of time, it would typically refresh the internal spreadsheet with all the data from the external workbook. So it's very simple and direct to link Excel workbook with the Simulate software.
All right, thank you, Krishna. Another question we had is, what happens if I don't have any data for my model yet? What are the next steps?
In case there is no data for the simulate model, what we can do is, if we know the process is going to be a part moves from, let's say, machine A to B to C, then we can keep placeholders for what and all information may be required for a machine A, B, and C, and go ahead with moving or building the simulation. And then when we get more information, we can come back and work on it. It's pretty fast to just change data input.
Yeah, I would echo that sentiment. I think we never want a lack of data to slow people down in getting a model built. There's a few things that we put in the software to actually try and make that easier so that you can just work with stakeholders who know the process or go and collect that data. But we have inputs such as triangular distributions, which allows you to ask people who know the flow, what's the longest amount of time it would ever take, what's the shortest amount of time it will ever take, and what's the most common amount of time. And those types of inputs allow you to get building that simulation quickly, because I think you can still glean quite a lot of value from a simulation. Even if it doesn't have perfect data, you're still going to be able to learn a lot from it.
Okay, thank you, Tom. That also ties in with our next question is what types of distributions are there and what type should I be using?
Do you want me to go? I can
Yep,
go
sure,
first
go
on
ahead,
this one.
Tom.
Yeah, sure. Yeah. So, well, there are a number of distributions that are built into the software, and we have a tool called StatFit that allows you to input your data and advises which distributions match that. You may have other programs that you use to do a similar thing, actually, that you can then input into simulation. I'd always recommend trying to match your data to a distribution because it's going to allow you to capture those different processes that actually sometimes take a little longer than normal and can slow a process down. So it's always advisable to do that. But sometimes you might have processes whereby you're working to a set kind of takt time, and in that case, you might get away with just having less detail and putting in using kind of averages or triangular distributions, as I mentioned before. Yeah, that would probably be what I'd say on that.
Yeah, I agree with Tom on that. So there are about, I think, 20 different distributions that is available in Simulate, and they're very helpful. And we can quickly set up different types of patterns that we require. But even in case we don't have that, we can always generate it using StatFit. Or if we have a large data range and we want to fit it into a certain graph type, we can always create some type of beta distribution using a probability profile that would always fit any specific data that needs a distribution to be built around it.
Yeah, that's a really good point actually, and we tend to do that quite a lot when you know the data is going to change quite frequently. Having a template that allows you to build that probability profile, I think, is really useful. So yeah, that's a really good point.
All right, thanks, guys. With that, I don't see any further questions to ask. So with that, thank you, Dave, Tom, and Krishna for that presentation and for answering those questions. For scheduled upcoming topics, at least in terms of PMC, be sure to visit our website at www.pmcorp.com and click on the Resources tab to register for other webinars. Also, be sure to visit our YouTube channel, search PMC videos, and that's videos with an S. It's all one word. There will be a recording of this presentation. If you want to review this presentation, review the slides, share it amongst your colleagues, we recommend you do so. That will conclude today's webinar. If you think of any additional questions, please contact us at the addresses now on your screen. And otherwise, thank you and have a great day.